Welcome to Hacking Podcast. Our investigation today is built on research from Oliver, a bright orange cat who observes our digital infrastructure from the shadows. Oliver's notes suggest that to understand the hacker, we must first look at how Hollywood misdirected us. In 1995, cinema gave us the romanticized, neon-drenched rebel, a contrarian who surfed through 3D data architecture on rollerblades. Modern media offers the opposite extreme, a grim realism defined by alienation. This version shows the hacker as a digital burglar, hunched in the flickering glow of an unlit apartment while dismantling the financial system. Oliver actually left a note in the margins here, confessing he'd love to have been a background extra in this scene, just a silent witness in the corner of Elliot Alderson's apartment. These cinematic archetypes, the colorful rebel and the depressed thief, distort the technical reality and the intellectual legacy of the culture. To find the actual descendants of original hacker culture, we have to look past the computer screen. We find them at workbenches, holding soldering irons and modifying physical hardware. The definition of a hacker shifted from a builder to a criminal over several decades. Restoring the original meaning requires us to return to the labs where the term was coined in the 1960s. The culture began at the Massachusetts Institute of Technology. In the 1950s and 60s, these halls became the birthplace of technical curiosity. Students in the Tech Model Railroad Club and early AI labs gained access to these massive mainframes. At the time, computing was a formal, highly regulated process governed by strict institutional rules. These students used the word hack to describe an elegant, creative, and non-obvious solution to a technical problem. It wasn't an act of intrusion, but an act of optimization. This curiosity solidified into the hacker ethic. It was the belief that access to technology and any information that explained how the world functioned should be total and unlimited. The core tenet was simple: information wants to be free. This created an inherent distrust of centralized authorities and proprietary, closed-box systems. This drive to understand the internal logic of a system laid the groundwork for an era of underground ingenuity that soon moved beyond the university labs. By the 1970s, the most dominant closed system in existence wasn't a computer network, but the global telephone infrastructure. John Draper, a central figure in the phreaking movement, discovered that a plastic whistle from Cap'n Crunch cereal boxes could manipulate this entire network. The whistle emitted a 2600 Hz tone, identical to AT&T's signal for an open trunk line. Blowing it into a receiver convinced the system they had administrative authority, unlocking free worldwide routing. This massive physical infrastructure of wires and switches was designed to be a black box. However, it was completely bypassed by anyone who understood the specific audio logic it relied on. Kevin Mitnick later demonstrated that these vulnerabilities existed in people too. His use of social engineering, manipulating human protocols to gain access, led to years in federal custody and shifted how the law viewed technical curiosity. Whether the target was a switchboard or a human being, these pioneers sought technical autonomy. They refused to accept the operational boundaries set by corporations or the state. As software became a highly commercialized commodity in the 80s and 90s, the original urge to dismantle to understand faced new barriers in the form of proprietary code. The philosophy didn't disappear. It expanded. The drive to understand internal logic moved from the digital screen back into physical hardware. We see this legacy in the modern maker movement. In these workshops, 3D printers and open-source circuits allow people to apply the 1960s MIT hacker ethic to the physical objects they own. By utilizing open-source hardware, individuals stop being passive consumers of technology that is designed to be unrepairable and opaque. A builder prototyping a device in their garage today operates on the same premise as the early mainframe students. They believe that the internal mechanics of our tools should be visible and modifiable by the person who uses them. The enduring legacy of the hacker is not a history of digital theft. It is the refusal to accept the world as a series of closed systems. It is the drive to take technology apart, understand it, and build it back better.